Hello, good morning, and welcome to DevDays Europe. I'm just posting some links in the chat already, so I don't forget when my session is over. So there we go. So I hope you are enjoying DevDays Europe so far. I'm going to quickly share my screen so that you can see my presentation and my demos. There we go. So again, welcome. My talk today will be about .NET 5 and what is new in .NET 5 and what the future of .NET will probably look like. So let's get started. So my name is Johnny Hooyberghs. I'm from Belgium. I work for a consultancy firm called Involved, and my main job is mostly doing backend architectural work in .NET specifically. I've been doing .NET since its early beginnings, and I'm very happy that I got that boat, that I joined the .NET platform in 2002, because it gave me the opportunity to learn it while going. With all respect for .NET, but I think when you're a new developer in .NET today, things are much more complicated because there's already so much available, so many technologies you can use, so many different paths you can walk within the .NET framework. When I started back in 2002, things were more simple, and I could see the .NET platform grow year by year. So as I told you before, I'm a consultant. I do mostly .NET work, and last year I received the Microsoft Most Valuable Professional Award from Microsoft, so I'm very thankful for that. And if you have any questions after this session, and there's no more time to ask me any questions live, I would encourage you to contact me using my Twitter handle or via my GitHub account, or you can just use my professional email address. I will be most happy to help everyone that has some questions. If you have questions during my presentation, you can use the Q&A inside of the Pine tool, and I will look at the Q&A during my presentation. So when I'm talking about something, you have a question, just ask the question using the Q&A. I will see it, hopefully, and I will try to answer it immediately. So you don't have to wait until the end of the session to do that. So let's get starting. Of course, let's open the Q&A so that I can actually see your questions, and then let's start. .NET, as I told you before, already exists since 2002, and the reason I jumped on .NET because I was already doing C++ development for Windows specifically, and I was using Visual Studio. So I was already deep into the Visual Studio space, and then for some reason, I got tired of C++. It was a little bit too complicated to do complex things. It took a lot of time, so I decided to join the Delphi community because Delphi by then was very popular and it had an easy way to create Windows applications. But then after about half a year that I was doing Delphi, .NET became available in 2002. And for me, that was very nice because I could go back to Visual Studio because I was used to working in Visual Studio. And basically, .NET got into a cadence where each and every year, there was going to be a new version of .NET. So in 2002, we got .NET 1. And then today, in 2019, we have .NET Framework 4.8. Also, .NET was very tightly coupled with Visual Studio. Whenever there was a new version of .NET, there was a new version of Visual Studio, because Visual Studio needed to support the new language features, but also the new SDK features and stuff like that. So those two were really coupled together. Of course, you could create .NET framework applications without using Visual Studio in the beginning. The compiler was a separate executable. You could just use your favorite text editor and then use the compiler manually. If you had a lot of knowledge about the SDK. Of course, in later years, lots of other IDEs became available to do .NET development, but still .NET was really tightly coupled with Visual Studio. And then in around 2019, a little bit earlier, Microsoft decided the world of programming languages, the world of computing is changing a little bit. There's more focus into open source development. There's a lot more focus into platform independent development. And the .NET framework already existed, as you can see, for almost 20 years. So there's a lot of legacy, a lot of stuff that actually is not so flexible when you want to make a move to, for example, multi-platform. So that's why Microsoft decided to create a new kind of .NET, and they called it .NET Core, because they were going back to the core. They redesigned and recreated the entire .NET platform, but of course they tried to keep it as close to the .NET framework as possible. So around 2016, we actually had two different .NETs. We had .NET Framework and we had .NET Core. And this is also around the time that I was teaching. I did some teaching for about 10 years where I thought adults during nighttime. So adults that go to work, and then at night I would teach them about .NET and programming in C# so that they could possibly go do a different job when they were finished with their studies. And for me, it was already a hard time by then to talk to my students and to tell them that there are two different kinds of .NET. There's .NET Core and there's .NET Framework. So if you're looking for documentation, you need to look very specifically for Framework or Core, because they are very similar, but they do have their differences. So if you find some Stack Overflow documentation on .NET Framework, it doesn't necessarily work for .NET Core and vice versa. But in 2016, Microsoft made the decision there's going to be a new .NET. And with a slightly new Visual Studio, they introduced .NET Core. And then the speed of the new version of .NET Core was very high. As you can see, there were about 1 or even 2 releases each year for .NET Core. The reason is, of course, they had to close the gap between the 20 years of .NET Framework, and then that new platform also needed to have these new features added very rapidly, so people would adopt them, because otherwise, when .NET Core was only a very, very small subset of .NET Framework, people would not use it, of course. So in 2016, it started, and then all the way until 2019, almost 2 years ago, we got our final version of .NET Core called 3.1. Because .NET Core was going so quickly, older versions of .NET Core also got out of support very quickly. You can see in the table in the bottom that most versions of .NET Core are out of support, which means that they will not receive any updates, they will not receive any security fixes, so you shouldn't really use them today. If you are doing .NET Core today, you can basically only use .NET Core 2.1 or 3.1, where .NET Core 2.1 will go out of support this summer. So only in 2 months from now, .NET Core 2.1 will also go out of support, and then you're left with .NET Core 3.1, which will go out of support the end of next year. So it's very important that there's going to be an upgrade path from there. So what about the future of .NET? Well, I am very happy for my students and for myself that Microsoft decided to unify the .NET platform into .NET, and that makes things even more complicated for the coming years, because of course now we have 3 kinds of .NET where we can talk about. We have .NET Framework, we have .NET Core, and we have just .NET. Don't say the just part, .NET. So .NET Framework, .NET Core, .NET. So in the future, hopefully there will only be .NET, but today we have some legacy. There's still many developers and many companies that use .NET Framework, because .NET Framework is still valid today. I will come back to that a little bit later. .NET Core is basically end of life at the end of next year. So from the end of next year, we shouldn't really talk anymore about .NET Core. And then we have .NET since last year. And .NET is actually .NET Core. So they changed the name .NET Core to .NET because they want to continue with .NET Core, but they don't want to say the core part always. So they just leave the core part out, and we just say .NET, which again is basically .NET Core, or a new iteration of .NET Core. And they also changed the versioning. So they're not going to jump from .NET Core 3 to .NET 4, because .NET 4 would be a little bit weird, because we already have a .NET Framework 4. I told you things get a little bit more complicated this year and the next years. So that's why they chose to go with .NET 5. So .NET 5 is actually .NET Core 5. And .NET 5 is not .NET Framework. Microsoft also decided that .NET will be the only thing going forward. So .NET Framework will also not get any new updates, which means that .NET Framework 4.8 will be the last one. It is still supported today, and it will still be supported for many years, is what Microsoft promises us. Microsoft tells us that .NET Framework is part of Windows, and as long as they ship .NET Framework with Windows, it will be supported, and that support will be tied to that version of Windows. So today, .NET Framework is bundled together with Windows 10. So it is tied to the end of life of Windows 10. So when Windows 10 does not go end of life, .NET Framework will not go end of life. And Microsoft knows that many companies and many developers are still using .NET Framework. It is still a very powerful platform, so it will probably be around for some time still, so you don't have to panic. But .NET Core is something that will end next year. .NET 5 is the first version of this new .NET platform. It came out last year in November. So my presentation today is a little bit outdated because this year in November, the new version .NET 6 will be available. And this one will be the long-term support version. So this one will be supported for 3 years. So if you are not yet using .NET 5, I would wait until .NET 6 in November, because that one will be the LTS version. And then you have less work to do, and November is not very far away. Each year, Microsoft will have a new major version of .NET. So they really want to speed up their development. They want to have new features more quickly than we had with the .NET Framework. And each odd year, they want to do a long-term support version, and each even year, they want to do some kind of an intermediate release so that we can jump more quickly on these new features. So again, this year, .NET 6, which is long-term support. Next year, .NET 7. The year after, .NET 8, which is also long-term support. If you want to jump to one of these versions of .NET, you just have to remember that the long-term support versions will be supported for 3 years after their initial release. 3 years only. So .NET 6 this November will go out of support in 2024, because by then you already have had 1 year of .NET 8, which is the next LTS version. So you basically have 1 year to migrate from one .NET LTS to the next .NET LTS. If you're using one of the versions in between, like .NET 5 and .NET 7 and .NET 9 and so on, they will only be supported for 3 months after the next LTS release. So .NET 5 will only be supported up until around February next year, because that is 3 months after the release of .NET 6 LTS. So something to keep your head on, something to remember. Again, .NET Framework is still out there. .NET Core will go out of support, and .NET is the future of .NET, and that will get a new version each year and a new LTS version every 2 years on the odd years. I'm looking forward to seeing Microsoft keeping up with this cadence that they decided on themselves. So we'll see what happens the next years. And of course, it's very important that .NET is becoming multi-platform. Microsoft already talked about .NET being multi-platform in the very early days of .NET. When .NET Framework 1.0 came out, Microsoft told us that .NET was multi-platform, and what they basically meant is that it was using kind of a runtime, and that runtime could be available on every major operating system, and .NET applications would then run on all of these operating systems. But Microsoft didn't create those runtimes for other operating systems. They only created it for all of their Windows versions. And of course, for some processor architectures like 32-bit x86 processors and x64 processors. But the option was there. You could create a runtime for .NET in Linux or on Mac or whatever. But Microsoft didn't do it themselves. And that's why there was an external group of developers that created a second runtime that would actually run on Unix, which was Mono. So if you are hearing about Mono, Mono is also a .NET runtime that runs multi-platform. So in that sense, .NET Framework was always multi-platform. But of course, it was always a little bit behind because they were external developers. They weren't really working together with Microsoft on a day-to-day basis. So it was not the perfect world. And that's why Microsoft decided to start again from scratch and really do the multi-platform themselves. Of course, we had some in-betweens. We had portable class libraries at some point in time. Portable class libraries means that you can create a class library and use that class library in different kinds of .NET platforms, because Mono was not the only runtime. Through the years, we had mobile development for Xamarin, for example, which is also using Mono, but then the Mono runtime on Android devices and iOS devices. But we also had Windows 8 store applications when Windows 8 was still a thing. We had UWP, Universal Windows Platform, which was also kind of a different runtime. And when you want to create like a NuGet package that could be used in all of these different runtimes, you should create like a portable class library that you could reuse. But portable class libraries were quite intensive to use. They were difficult, so people were not really happy with that. So Microsoft abandoned the concept of portable class libraries. And then with .NET Core being really multi-platform, Microsoft decided, okay, but there are still going to be developers that want to create NuGet packages or libraries that can be used both in framework and in core. So they decided there's going to be like an overlap. .NET Core and .NET Framework, they have most of their things will overlap. The classes will be the same, the methods will be the same, so people should be able to reuse the libraries in the two. So they created .NET Standard. And .NET Standard is yet another framework, you would think, but that's not true. .NET Standard is just a definition of what is the intersection between .NET Core and .NET Framework. So if you create a class library and you target .NET Standard, it doesn't target a framework, it targets the intersection between .NET Framework and .NET Core, so you can use it in those two frameworks, which also means that you are quite limited, because things that exist in .NET Framework but that don't exist in .NET Core or vice versa, those things are not available in .NET Standard because they are not in that intersection. Microsoft then decided, yeah, things are getting complicated. We know things are complicated. Excuse me. So people are having difficulties. So let's again start from scratch concept-wise. And with .NET 5, there's really going to be a unified platform. You just create .NET class libraries, .NET applications from .NET 5 onwards, and they will support as much as possible. And if you still want to do .NET Framework development, of course, you can still do that. But I would suggest for modern and new applications, go with .NET 5 or .NET 6 this year. Because, of course, .NET Framework will end someday. As I told you, .NET is going to be a really unified platform. Microsoft decided to introduce Windows development back into .NET Core already with version 3, but now in .NET 5 also. It's not fully platform independent, creating WinForms, creating WPF applications. They cannot run on Linux, they cannot run on Mac, but they are part of .NET 5. So it is a unified platform in that sense. There's lots of investment in cloud. Of course, mobile is going to be is a thing in .NET 5. You have Xamarin support still, and Xamarin will also evolve in the next coming years to something that is even more unified within the .NET platform, looking at Project Maui. So Maui will be part of .NET 6, which is basically the evolution of Xamarin development. Unity is also something. Unity was using C# and the .NET runtime as their backend. Today it's Mono. Hopefully tomorrow they will also join the unified .NET platform and they will use the same runtime. But I know that the people from Unity are still in discussion with Microsoft on exactly how they are going to do that, because Unity is, of course, very popular today. IoT, .NET 5 today is already supported on ARM process architecture, so you can run your .NET application on ARM. ARM Linux or ARM Windows both work perfectly fine. I already used .NET on ARM 64 using Linux, and that works perfectly fine. And Microsoft also wants to introduce AI, machine learning, .NET, and all those kinds of things inside of the unified platform. I told you before, .NET was tightly coupled to Visual Studio. That's not the case anymore today. .NET is its own has its own SDK using command line interface. So whatever you can do in Visual Studio, you can also do from the command line, which means that .NET can evolve by itself without a new version of Visual Studio. Of course, when .NET introduces a new kind of development template, where you can create new kinds of development applications, Visual Studio also needs to incorporate this into its UI. If you want to do file new project, those project templates need to be available. But behind the scenes, it's just going to use the command line interface. If you do .NET New, you can just specify what kind of .NET platform you want to create, what kind of .NET application you want to create. If you want to create an ASP.NET Web API, for example, you can specify that command line. And .NET will, Visual Studio will do the same thing behind the scenes, but it will show you a nice user interface so that you can just click through a wizard and create that for you. So they are now completely separated. .NET can evolve. If .NET needs a fix, it can just have a new release without a new release of Visual Studio, and vice versa, which is very cool. I told you before, .NET 5 is just the next version of .NET Core, but it's evolving from there, and it's not related to .NET Framework, so those are two completely different things. And of course, .NET 5 and .NET Core are fully open source. You can find the complete source code on GitHub. So if there's an issue, you can create an issue on GitHub. But if you want to learn a little bit more how a function internally works, you can just look at its source. I've used that for many times already. If you're using some kind of function on a string, and there's also something else that you can do to achieve the same goal, and you're wondering what is the fastest way to do this, or what is the best way, look at the source code. Look and see what happens behind the scenes. Maybe one function will just call the other one in the background, so you will know that they are basically doing the same thing. Just look at the source code and learn from that. Very, very interesting. And with that, that's my first part of the talk. The next part will just be going through some of the new features. I have many more than I have time for, but I will just see where I get. I told you before, with .NET 5 and in the future of .NET, there's going to be a single SDK experience, and this is also true for the project files. So in the past, you had different kinds of project files. Today, a project file for Xamarin looks very different than a project file for a console application, which is not fun. As a developer, you want to have something more unified. So in .NET 5, basically all project files are XML files, but they are a lot more simple than they were in the .NET Framework. You basically specify which SDK you're using, and an SDK can, for example, help you with a console application, which is just a .NET application, or an ASP.NET MVC application uses a different SDK. It's the Web SDK. It has additional support for different things, so that's a different kind of SDK. And you also specify which version of .NET you are using. So from that .NET 5 onwards, this is the way how you specify the platform you're working with. So .NET 5 is just .NET 5.0. But if I go back to my presentation, if you specifically want to target Windows application, like for example with WPF and WinForms, you can't just say I'm doing .NET 5 because .NET 5 is really platform independent. You need to specify .NET 5-Windows. And now your compiler knows that you're specifically targeting Windows, and that application will only work on Windows. But from .NET 6 onwards, we will have different operating systems supported here. You can do -Android to create a Xamarin application. And now the project file is very similar to a console application. It's just going to tell us this will only run on Android, or it will only run on iOS. And even later in the future, I hope we can do stuff like Linux or macOS to create applications for macOS and so on. So it should be a lot simpler for us to define this. I did some examples. Here you can see for WinForms, we just have -Windows. For WPF, we also have -Windows. The only thing you need to add is use WPF or use WinForms. The reason for this is just that the project file tells the .NET SDK if you're using WinForms UI or WF UI to help us to create those applications so that the SDK has some additional features for us. By the way, you can actually see this. The top project is just using .NET 5. And if you open it up and you look in the dependencies, you will see inside of framework, we are using Microsoft Net Core app, which is the base SDK that we're using. This is not a NuGet package. This is basically a part of the .NET SDK that we are compiling against. If you look at the WinForms version, you will see that in frameworks, you still have .NET Core app, which is the base for all .NET Core apps, but you also have Windows Desktop app, Windows Forms. So this is an extra part of SDK that we're using specifically to target Windows Forms applications. And then, of course, in WPF, we have the WPF variant. So that's the other one. So just by telling our project file which version of .NET we are targeting, we automatically get dependencies to the correct SDK features, and those will help us during development. New namespaces will become available. We can use those namespaces, and the compiler will know what we are doing. I'm going to give you one extra example. I'm not going to use the correct order here, but example 8, so a little bit into the future. There's even more things you can do. From Windows 10 and Universal Windows Platform, there's lots of additional things we can do from our Windows applications. We have new APIs that we can use to access the disk, to access specific hardware like GPS chips, like webcams, for example. But those are not available in like WinForms or WPF by default, because WinForms and WPF work with older version of Windows also. You can run a WPF or a WinForms application on Windows Vista or Windows 8 still today. But if you're targeting Windows 10 specifically, you can use that target framework, and you can even add an additional version number. And when you add an additional version number, you will see that those dependencies will even have an added Windows SDK to them. Now we're not just targeting Windows, we're targeting Windows 10 with that specific version, and we have a reference SDK that can help us to unlock additional features. So what happens here is that I created a WinForms application. If you are into WinForms, and if you have some patience, okay, this gives me some time to drink. I would not suggest to have 10 Visual Studios open at the same time. It's not helping me with this demo. So yeah, while this is loading, oh, okay, it's there. So this is a button and a picture box. And the button says take picture. And when that happens, I am using media capture. I'm using image encoding properties. I'm using known folders, stuff like that. These are all very specific Windows 10 APIs. And this gives me the opportunity to very easily use my my webcam, which is not available by default in WinForms and WPF. So let's give you a little behind the scenes picture here from my webcam. So this is from my webcam, and that's the reason why I'm not using my webcam, but a dedicated camera, because my webcam really sucks. So you can see this is now taking a picture with my laptop webcam. Of course, when you just remove the additional version number from your Windows target framework and you save, automatically that dependency will be removed. It's now gone. And if you go to the source code, you can see that all of those classes are not available anymore. So the compiler cannot find them because that part of the SDK is not available, and these namespaces are not available. So that's a very cool feature. If with the newer versions of Windows, there is going to be newer things that we can use, new namespaces that will be unlocked, you can just use them by changing this version number. And basically that version number tells you this application needs at least this version of Windows. It will also work with newer versions, but it will not work with older versions. You can find a list online in the documentation which version targets which release of Windows 10 exactly. Like this one is, I think it's the first version of 2020 last year of Windows, but you can find that online. So that's that. Something that is not really a new feature, it's already there from .NET Core, but I think it's very important for you to know that it's there, is that with .NET Core, because your .NET applications are platform independent, basically it's not creating an executable like you would think of today, like you would think of in .NET Framework. An executable in Windows is basically a .exe file, and you just double-click that in File Explorer, or you create a shortcut and you launch it like that. That is your executable file. And in .NET Framework, that is actually a fake executable file. It's not a real native executable. It only has a header, which is a real executable file, which basically launches the .NET runtime in the background. And then the second part of your executable contains your .NET intermediate compiled code. So if you don't know, .NET basically runs on a runtime. So when you compile your C# code, it does not compile to native code. It compiles to something intermediate, which is not machine code. It's not very platform dependent. It's platform independent. And then when you run that, the .NET runtime will run in the background on your computer, and it will just in time compile that intermediate language into real machine code for your specific machine. In .NET 5 and .NET Core, the same thing happens, but it's going to be split up into different files. The executable will just be the wrapper that runs the .NET runtime, but it will only be that wrapper. And then there's also going to be a DLL file, and that DLL file will basically contain your intermediate language code. So even when you're creating a console application and you look at the output from that, so bin debug .NET 5, you will see that you have both the executable and the DLL. The executable is just a real native executable, and it's quite large. It's 125 kilobytes, which is very large for a console application that just says hello world. But this does not contain your hello world console application. The DLL contains your hello world console application. So it's very important, if you're new to .NET Core and .NET 5 and you're coming from .NET Framework, don't just copy the executable. Always copy the DLL with that. And you can basically see that with ILSpy. ILSpy, if I open it correctly, is a tool that is able to decompile .NET applications, because basically they're not native code. And if I drag the executable, you will see that it says that the file is not supported because it is not a .NET file, it is a native executable. But if you drag your DLL file, you can see that this actually contains your .NET code. It has my namespace, it has my program class, and it has my program method, which is empty. But it's there. It doesn't even say hello world, and it's still 5 kilobytes. So just remember that. In the first version of .NET Core, by the way, there wasn't even an executable. There was only the DLL, and you needed to start it command line. If you build this for Linux, for example, the DLL file will be exactly the same, but the executable will be different, because an executable on a Linux operating system is different. So remember that, default executables. The executable will be created because you're debugging on a Windows machine. If you're debugging on a Linux machine, the Linux version of that executable will be created. That's why it's called default executable. The third thing I want to talk about is single file applications. I'm not actually using that, but it is maybe a cool feature when you're just wanting to create small tools and you want to just put those tools on a floppy disk or on a USB drive, and you want to give that to your co-workers or to your family or whatever. Basically, that gives you the opportunity to, instead of creating a single DLL and an executable, and the .NET runtime needs to be installed on that user system, you also have the option to already compile it for a specific platform, which means that your user does not need to install the .NET runtime beforehand. I told you your .NET application needs the runtime, and the runtime needs to be installed on that operating system. But with this, when you specify in your project file the runtime identifier, you actually specify this application will run on Windows 10, 64-bit, and it can only run on those kinds of machines. And then the user does not need to install the runtime beforehand, because the runtime will be compiled with your application. But it looks very, very frightening. If I publish this single file application, publish, I can drink some more. Yes, and I look at the output directory, bin, release, .NET 5, you can see that there's an additional folder. Now there's a folder for Windows 10 64-bit specifically. Now this is your application. It is 226 files, and it's about 66 megabytes in size. So this is your completely compiled application that is a console application that does nothing. If you give this on a floppy drive, that doesn't work because a floppy drive is too small, but on a USB stick to your family, they will be very suspicious. If you create like an I love you grandma application and it looks like this, and your grandma is smart enough, she will think this is very suspicious because there's too many files. Those files are very large. You are probably trying to hack her computer. But now with single file applications, you just add one additional parameter to your project file called publish single file equals true. And then inside of your publish directory, you now have something that Microsoft calls a single file, but it's actually 5 files. This is now your complete application. You can copy these files to wherever. .NET does not need to be installed. It will run as long as it's a Windows 10 a Windows 64-bit machine. Of course, your grandmother will maybe still be very suspicious because when it just says, hello, I love you, grandma, 50, in this case, it's 52 plus the other ones is probably the same thing, 66. Let's see. My Explorer does not want to work today. I'm not getting anything. So yeah, it doesn't matter, but it's still very large. But it looks less frightening. So that's public single file applications. There's basically one more thing you can do, which is called assembly linking, which is a little bit weird. But when you even add one more of these things, publish trimmed equals true, it basically strips out everything that you're not using from .NET or everything it can. And then the resulting file size will be smaller. I'm not going to show you, but now you don't have a file of 50 megabytes, but it will be around 10 megabytes only. But of course, it's a little bit more dangerous because if you're using reflection a lot, your compiler does not really know what classes you are using, so it will maybe strip out a little bit too much. So that's not something that you would like to do. But you can experiment. You can see if your application still works after trimming all of the features that you're not using. Hardware intrinsics is something that I found is very cool. You can talk to your CPU directly. I'm not going to talk about the specifics. There's separate namespaces you can use for that. But basically, it gives you a very large speed up when calculating mathematics. So basically, you can, just like C++, you can target very specific processor instructions from your .NET application, which is very cool. You can see that I run 3 different kinds of calculations. I'm just adding 1 billion integers together. And when I'm just doing it with a for each loop, it will take around, let's take the last one, 1 second. When I'm using SIMD, which is a processor thing, which is single instruction, multiple data, so you can do stuff in parallel using vectors, it only takes half of that. And then when I'm using Intel SSE2 specific instructions, it goes even half of that. So it's times 4. So those instructions are available. This example is available for you on my GitHub, so you can take a look there. There are some new development templates also. So from .NET Core onwards, things are a little bit different. For example, ASP.NET today looks a little bit different in .NET Core and .NET 5 than it did in .NET Framework because it needs to be platform independent. For example, in .NET Framework, you would need a web server in the backend that can run ASP applications. And for most people, it's going to be IIS, Internet Information Services. In .NET Core, it really needs to be platform independent, and it needs to be supported in cloud environments and containerization and stuff like that. So now ASP.NET Core or ASP.NET in .NET 5 has its own built-in web server. So you can basically run your web applications from a console and it will just work. And that's what I'm doing today on a Raspberry Pi for some internal stuff at home. It runs its own web server. I can just communicate with that web API from within my own home network, which is very cool. But there's also other kinds of development templates that we were using that were very Windows specifically, like, for example, Windows services. So a Windows service is a program that runs in the background. It doesn't have a UI, but it does some maintenance tasks, or it does some continuously doing things in the background. Of course, the same concept exists in Linux. In Linux, it's like a Linux service. It runs in systemd. It's a Linux daemon. It's the same concept, but it works a little bit different. So in .NET Core, Microsoft introduced a new template called a worker service. And a worker service is just a console application that can do continuous work inside of a loop. There's a specific template for that. There's specific classes for that. But it is a console application. And I very much like that, because I can just debug the console application by debugging it, by just starting it. It runs as a console. I can see what's happening. I don't have to install that as a Windows service first. But then when you want to deploy that, you can just add a NuGet package that helps you to put like an envelope around it so that it will be compatible with a Windows service. And you can install that using command line tools as a Windows service. But you have a different NuGet package that can do the exact same thing for Linux. So now you're creating a daemon that you can host in systemd, which is very cool. You have the same application and you can deploy it in different kinds of operating systems and their interpretation of what a background service should do. So very cool. There's also gRPC, which is a different kind of HTTP communication, which uses a different protocol. I'm not going to show you right now, but those are those different kinds of templates that will be future-proof and that will really work on different environments. So to finalize, I will show you some of my favorite new C# features. So basically, C# is also not really tied to .NET, but the releases are somehow in sync. So .NET will release each year, so .NET 6 this year, and because of that, there will also be new C# features. So C# 10 is going to be the one that's going to be released this year. C# 9 is the one from last year. There's a couple of new features that I want to show you. And basically, the reason why C# also has a new version each year is because a couple of years ago, Microsoft created a new compiler for C#. The old compiler from C# was written in C++. Of course, because when you create a new language, you need another programming language to create a compiler. But today, C# is a very powerful language, so Microsoft created a new C# compiler in C#. So Microsoft used the C++ C# compiler to compile their C# code for the new compiler, and now they have a new C# compiler that was written in C#. Very cool. And that can also be compiled with itself. Very cool. And because of that, things became very easy for Microsoft to create new features because their new compiler is created better. And that's why each year there's many new C# features. One that I very much love as a teacher is the top-level programs. So Microsoft decided, okay, if you're just creating simple console applications or even simple other kinds of applications, you don't need all of that ceremony. You don't need namespaces. You don't need classes. You don't need methods. If you just want to have a quick script that does something, or I love you grandmother console application, you don't need all that stuff. You can just leave it out. So this is how you now can write console applications and they will just work. Very cool. Also, as a teacher, when I want to talk about how an if statement works, I can just write it like this and my students will not get confused. Then maybe the most important one for me is init-only properties. So in the past, you could create properties with a getter and a setter. You could create read-only properties with only a getter, but those properties could only be set inside of your constructor, which means when you're not using a constructor, but you are using it like this, equals new, and then your properties like this. I forgot the exact name in English, how you call this. It's an object instantiator or something. You weren't able to do that. Like here, this does not work when you don't have a setter. From C# 9 onwards, you have a new keyword called init. And in it, gives you the opportunity to also only be able to set it from within this, this construct here. But it doesn't work like this. You need to do it within the object initializer. And then finally, we have records. And records is a new kind of class that gives you the opportunity to create immutable objects. And with that, I'm at the end of my presentation. And again, you can find everything on my GitHub page. You can contact me if you have any more questions. I will look at the chat for some time now. And I hope you enjoyed this session, and I hope you will enjoy the rest of DevDays Europe. Thank you.